Welcome to Module 8. Not sure if you heard by now, but this is actually our last module. The end of quarter 4 is going to focus on making sure that all your work is completed for all the other weeks and modules that we've been home or distance learning. And so this is the final week that you'll be getting new content. Because of that, I kind of had to make a decision because there were some units that we hadn't yet gotten to. So I had to choose between urinary, lymphatic, and reproductive. And I decided to go with reproductive. I think it's very important that you be familiar with your body, and I think that the reproductive system can sometimes get left behind in health classes, and I think it's important that you be familiar with yourselves as well as the opposite gender, or the opposite sex, I should say, and understand the physiology and health related between the two. So let's go ahead and dive into function. We're going to start then with male anatomy and the physiology of the anatomy components. Then we'll work on female anatomy and the physiology components of that. Normally I would like to cover a little bit of fetal development, but we're not going to have time for that. So instead I'm going to talk to you more about the various cycles related to females. So let's go ahead and dive in. Sorry if you hear crinkling and stuff. My husband's making lunch. Don't mind him. Oh, and Buford's snoring too, so. Okay. So, whole purpose of male reproductive system, well, any reproductive system, both male and female, is to produce gametes, right? So gametes are going to get to the end goal of having a baby because that's what life's all about. You got to make more of yourself from a biological standpoint. So the male gametes are sperm, and the male reproductive tract is simply there to deliver sperm to the female reproductive tract. Simple as that. The female, on the other hand, it is up to her to produce gametes, which are ova or ovum, if you're talking about one. In other words, eggs. And if that ova is met with sperm or fertilized by sperm, it is then up to the female to provide a protective environment for the embryo, which will later develop into a fetus, all the way up through birth. That's the purpose. Your reproductive system is to produce offspring from a biological standpoint. Okay. So let's go ahead and talk about anatomy. I think you know by now that I tend to jump around these diagrams, and that's exactly what I'm going to do because I want to go in an order that I think makes sense. So I'm going to try to do so. So starting off, we just have two illustrations here, one of an uncircumcised penis, the other of a circumcised penis. Only difference here is that the uncircumcised penis has a foreskin. Some individuals have this removed from their newborn sons based on personal preference or based on religion. There is no health hazards, benefits to either or. It just kind of comes down to the decision of the parent. Occasionally, there might be a need for it to be removed in adulthood, but it's not as common. It's typically a decision made by the parents during infancy. So from there, the penis is going to be shared by reproductive and urinary needs, and that means that the channel through the penis, which is the urethra, is going to be multifunction as well. It's going to be part of the reproductive tract as well as the urinary tract. We'll get to a little bit more about that in just a bit. The testes are going to be inferior to the penis, and they actually are outside of the body to ensure temperature regulation. You have lobes within, well, the male sex has lobes within the testes that are going to aid in spermatogenesis. So genesis is the term meaning the creation of or formation of. So we're looking at the creation of sperm. And these lobes, we've got this structure that is a coiled tube that spermatogenesis occurs through this journey through this tube, and that tube's called the epididymis. So as the sperm are making their way through the epididymis, by the time they get to the end of that tube, and it's a long journey, like 20 feet long of coiled structure there, the sperm will finally be mature. Once the sperm is matured, it can then go into the vas deferens. This might also be called the ductus deferens. Vas deferens is what I personally think is more commonly heard. And it's this long tube here that, hopefully you can see my mouse, is connecting the epididymis all the way up here above the urinary bladder and around here. That vas deferens is going to take the matured sperm and give it a pathway to the ejaculatory duct, which is not actually on this diagram, but we'll talk about it in a sec. And just next to the vas deferens, or at the terminus of the vas deferens, is the seminal vesicle. Sperm that has left the epididymis is not the same as semen. Sperm is the cell. However, semen actually has multiple components. It has fluid because the sperm cells need to have mobility by swimming. There's going to be various proteins and sugars within semen to help nourish the sperm. So that's what the seminal vesicle is going to help with. The seminal vesicle is actually going to produce about 60% of the fluid that goes into semen, the components there. So the vas deferens and the seminal vesicle are going to meet up here at the ejaculatory duct so that they can come together so that we have sperm in the semen. And from there, we're going to pass through, the prostate. The prostate is a gland that surrounds the urethra, and the prostate's going to activate the sperm. And then, before they make their way through the urethra, we need the assistance of the bulbourethral gland to make its secretion. Earlier I mentioned that the urethra is for both urinary and reproductive. Urine is acidic, and sperm and semen, I should not use them synonymously. Sperm cannot survive in an acidic environment. So semen has a very specific pH. It's typically neutral, around 7-ish. Maybe a little more alkaline, but it if there is urine left within the urethra, that acidity will kill the sperm that's within that semen. So the bulbourethral gland is going to release a fluid called pre-ejaculatory fluid. You might hear it more commonly called pre-cum, and this pre-ejaculatory fluid is going to flow through the urethra, one, for lubrication during sexual intercourse, but two, to rebalance that pH and remove any acidity that might be remaining in the urethra. So that way, once that pH is no longer acidic within the urethra, you can have the sperm that comes from the vas deferens combine with the fluids produced in the seminal vesicle, become activated by the prostate, and then make their way through the urethra and ejaculated from the penis. So that is an overview here, but we do have a couple other views to go over. So here is a mid-sagittal view. If this individual had been cut in half, we are looking into the right side of their body. Here, just to give you an idea, is the pubic symphysis. This is the front of your pelvis. So when the two pelvis bones come together, where they meet is the pubic symphysis. We mentioned back in skeletal that the angle below the pubic symphysis, if you're sexually a male, then your pubic symphysis is less than 90 degrees. If you are sexually a female, your pubic symphysis is greater than 90 degrees, right? And so this is just showing you the pelvic bone, right? So all these structures up here are within the pelvis. Okay. Outside of the pelvis and in the penis, there are different tissue types. You have the corpus cavernosum and the corpus spongiosum. These areas, you can see how they've got it like speckled here. This area is going to allow blood flow and engorgement, and so that's what is going to cause the penis to become erect because so much blood is able, or volume of blood is able to travel through that area. The urethra that travels through the corpus spongiosum is referred to as the spongy urethra. The tip of the penis is referred to as the glans. And then the technical name for the foreskin is the prepuce. Now, the prepuce, you'll notice when we get into the female anatomy, is also present in the female. So there's actually quite a few anatomical features that are similar between the male and the female. And it becomes much more obvious in fetal development because the beginning of our development as a fetus is generally the same until we begin to distinguish, in the later weeks between male and female. So a lot of the structures are the same until our cells begin to differentiate. So let's continue. The testes, as I mentioned earlier, are inferior to the penis, and they are outside of the body to ensure that the temperature is regulated. Sperm cannot survive in body temperature, and so that's why they are descended. They descend around puberty, so young males, they're a little more elevated because spermatogenesis is not occurring yet, so it doesn't really matter if they're kept at a warmer degree. However, once a male has reached an age where spermatogenesis is possible after puberty, it's important that those testicles have descended so that the temperature is not too hot. Um, the epididymis, like I said, it's this coiled structure. I just noticed I have an error there. For some reason, it says body twice. But it should actually be body and head of epididymis. Sorry about that. But through all these coiled channels, this is where spermatogenesis is occurring. And so that by the time it gets to the head of the epididymis, spermatogenesis is complete. Again, this is your bulbourethral, or the male's bulbourethral gland. This is what's going to produce that pre-ejaculatory fluid. You can see here where it connects to the urethra, and that's going to help flush the acidic pH. Here we have the prostate. Again, the prostate is going to activate the sperm. And then finally, here is our seminal vesicle. The seminal vesicle is producing the fluid that is semen to be mixed in with the sperm. Okay, if an individual, say, is producing faulty sperm, the seminal vesicle will still produce semen. It will just have low sperm count. Or say if a male has a vasectomy where the vas deferens is snipped, sperm or spermatogenesis, any sperm that's produced will not be connected to the ejaculatory duct. And so even though a male is no longer ejaculating sperm, there's still semen being produced by the seminal vesicle. That seminal vesicle is just, or that semen is just sterile, meaning that there's no sperm. Okay. All right. Ones that we've covered the testis, which is one, testes for multiple. We've covered the epididymis. Epididymis is where that spermatogenesis is occurring, so the making of the sperm. And then we have the pampiniform plexus and the testicular artery. These tissues in here still require circulation. And so that's what's happening here. We still need circulation to these tissues, nutrients to those tissues, and that's what these veins here are doing. You also have this muscle, it's kind of illuminated on both sides here. This side, it's been cut so that you can see the testes. This side, it's still intact. This is the cremaster muscle. Hopefully you can see that. As well as connective tissue that we call fascia. I mentioned earlier that the testicles are descended below the penis. The cremaster muscle is what's going to elevate the testicles if temperature becomes too low. So help warm the sperm to a habitable temperature. Whereas if the body heat becomes too low, too high, the muscles will lower so that the temperature can be cooled. So the cremaster muscles are going to be a raising and dropping effect to help with temperature. The scrotal skin and the dartos muscle is also very similar here. However, it's just going to constrict instead of up versus down. It's more of a surrounding contraction. Okay. I think this is our final male diagram. This is just to give you another idea here. We're just going to fill these in, and then I'll talk about them. So again, here we've got the lobules of the testes, okay? We've got the epididymis, so that we're having spermatogenesis. It's then leading into the vas deferens. So here's the vas deferens, right? The vas deferens is wrapping around the seminal vesicle. Here's the seminal vesicle producing semen. And this is where the sperm is then added to the semen. here at the ejaculatory duct. So that way, once the male is aroused, the bulbourethral gland will release pre-ejaculatory fluid so that the pH is neutralized, and then that will allow the sperm and the seminal vesicle, the semen, to then mix, travel through the prostate so that the sperm is activated and then can be ejaculated through the urethra so that the sperm is activated and within semen that it can swim through, and it's not going to be harmed by any residual acidity. I think that covers everything. All right, let's talk about the female. If you have any questions, feel free to send me a message. I'll get back to you as soon as I can. I know I'm kind of going through this. I know it's kind of rushed, but I want to make sure that you get all this info because it is a lot. So let's talk about female anatomy here. This is just a basic overview. If we start at the breast, you have the areola, which is the area surrounding the nipple. This areola, it can contract and relax, so the size or diameter of this can change. It's also interesting that during pregnancy, the areola will become darker. This is said to be an evolutionary trait that assists the newborn with breastfeeding because the darker color is likely to be picked up by their sight, and so they're more likely to see it and use that as a target for where they need to be feeding. So our mammary glands, or the female mammary glands, are going to lactate following birth to produce breast milk for the newborn. And this is like a exocrine production here. So there are cells that are producing the words will come to my brain. Lactation glands that are producing the milk, leading it into the ducts and draining there. Sorry, that's not the best vocabulary. I apologize. Okay. If we start from the bottom up with this overview, we have the labia minora, minus if you're talking about singular. From the labia, you go to the vagina. From the vagina into the uterus. You have round ligaments that are supporting the position of the uterus. You then have the uterine tube, also known as the fallopian tubes, and that's going to help connect the uterus with the ovaries. Let's move on, shall we? All right, so just real quick, I want to talk about the breasts and breast cancer. It's very important that females do self-inspection on a month. They recommend on a monthly basis. If you're not sure how to do this, there are videos of medical professionals going over how to properly check yourself for masses. You can also speak with your doctor about this, whether it be your general physician or gynecologist, but they can talk to you about how to check for growths as well. So really, the purpose of checking monthly is just to make sure that things aren't changing. One of the things, you have lobes and you have glands within the breast that can feel like lumps, but they might actually just naturally be there. And so doing a monthly check, you'll know what is normal for your body, and you will definitely know if something has changed. All right. So first off, you have different sinuses and ducts in the breast. These aren't going to be activated until um, you know you have till post pregnancy. But the mammary glands themselves can also become um, inflamed at some times. But then the other thing to consider is you have lymphatic vessels running through the breast tissue as well as lymph nodes. And this is why I mentioned that you'll be able to sense when there's changes and you can monitor changes. Your lymphatic system or your immune system involves lymph fluid, and sometimes fluid can drain and gather into these ducts and into the nodes and cause swelling. So sometimes that can cause concern, but really it's normal for that to happen. So you want to know, or you want to be able to monitor if it clears up or if you need to see a doctor, etc. The other thing with having lymphatic vessels run through the breast tissue means that it's very easy for cancer to spread. Once cancer enters the lymphatic system is essentially a highway to the rest of the body. Because your immune system is traveling throughout the rest of the body, if cancer cells were to metastasize into the lymph vessels, they essentially can travel wherever they want to go. And that's how you can hear of, somebody having breast cancer, but they found a tumor in their brain. Okay, a friend of my family's, she was I think she was stage 4 breast cancer, but the biggest part was that she had a tumor in her brain because the cancer cells entered the lymphatic system and were able to travel through the body. All right, let's talk about the genitalia. We are looking at the inferior view, and here's the pubic symphysis. So this is where the pelvis halves meet up. So here you can see the iliac spine, right, all the way up here. This is the pubic bone, okay? The fatty tissue that's on top of the pubic symphysis is called the mons pubis. And then let's talk about the rest of this anatomy. I know there's a whole lot going on here, but I think it's important that you know this terminology because, it's your body, or, well, if you're genetically female. So let's talk about that. All these structures in this upper area are within the urogenital triangle. Everything in the bottom one is the anal triangle. The only thing in the anal triangle is the anus. The urogenital triangle, this area going from here to the bottom of this triangle, is also referred to as the vulva. I don't think that's on this diagram, but it's common terminology that I think you should know. From mons pubis, not technically, but actually below mons pubis, to the posterior region of the labia is the vulva. Similar to the male, females also have a prepuce. It's also referred to as the clitoral hood. So if, as a fetus, this individual were to develop into a male, this would have been the foreskin, but because they are genetically female, it develops into the clitoral hood. And the clitoral hood is what is covering the clitoris. This is where we've got, sorry I keep saying we females, this is where females have, thousands of nerve endings. However, it's not just an external structure. It does continue to the internal region, and we'll see that in a cross section in just a bit. There are two labia sets. The outer labia is the labia majora. So labia means lip, so the larger lip. And then the labia minora is the smaller lip, or minus lip. All right. In between the labias, we have the urethral orifice. So this is where the female urethra is going to exit. So this is where females urinate from. Just posterior to it, you have the vaginal orifice. So the opening of the vagina. And then you have this greater vestibular gland. There's actually two of them. There's one over here, but it's just not really shown. This greater vestibular gland is essentially synonymous to the male bulbourethral gland. So for the male, the bulbourethral releases pre-ejaculatory fluid down the urethra. The female urethra is not linked to reproductive, so the greater vestibular gland is what's going to release pre-ejaculatory fluid for lubrication. And I think that's it from this view. Yep. So let's move on. Here we are with the inside. I know there's a whole lot going on here. So let's break it down, shall we? I mentioned before, the clitoris is actually an internal structure. It just has nerve endings that are exterior. So here you can see it actually does wrap around internally. You have the two labias here. It's majus and minus if you're talking about just one. Majora, minora if you're talking about both. So because this is a cross section, meaning that she's cut in half, we're only looking at one. These labia are going to be kind of like protectors for the vagina, the vaginal orifice or the opening, because obviously you don't want any debris or anything getting up there, so it's going to help with that, as does pubic hair. So here you have the vagina. The vagina is this tube here, this pathway. Okay, and when it comes to sexual intercourse, this is the area that the penis enters. The penis does not enter the uterus. Okay, the uterus is actually pretty far up, and so the penis does not go into the uterus. It strictly stays within the vagina. The uterus has two regions, though, here in this photo. The cervix is the opening of the uterus. If you see it from an inferior view, it kind of looks like a donut. Sorry, I don't know how. Bagel. I only have food references. I'm sorry. And the top of the uterus is the fundus. Because of its volume, we need support of it. So we have these round ligaments. As a female becomes pregnant, these round ligaments actually stretch, and it's quite painful. And that's just because the uterus still needs to be supported. Behind the uterus and between the rectum, there's just this space here called the rectouterine pouch. Off of the uterus, though, you have this uterine tube, also known as the fallopian tube. You can use either term. And the uterine tubes or the fallopian tubes are going to be kind of the pathway between the uterus and the ovaries. Okay, the ovaries are where it's oogenesis. Oogenesis is production of eggs or ovum. And then the ovaries are going to be supported by the suspensory ligaments. Okay, so these suspensory ligaments are going to connect to the pelvis and help maintain their location. This is a coronal section, so if you were to cut the female anatomy in half into front and back, so we're looking at a half cut here. So here would be the vaginal orifice. So this is the vagina, this pathway here. Within the vagina, a bit lower is this excess tissue called the hymen. It's typically intact through, younger years. However, it is quite often that it can tear. It definitely tears if there's sexual intercourse, but it can also tear just from injury. So the hymen is not a very good indicator of virginity because it can actually be torn in just from physical activity, really. Anything that kind of moves your body, or the use of tampons, or if you're a cyclist or equestrian or anything like that, it's very possible that the hymen can tear from that. So again, the hymen's not really going to be a good indicator of virginity. Okay. You also have these ridges here called rugae. I mentioned earlier that the penis is not going to go into the uterus. That's because the vagina can actually change length. During stimulation, it can lengthen so that it will, be the only location that the penis is within. The other thing is that during childbirth, right here, let's see. Hang on. Okay. Right here is our cervix, or the cervix, I should say. As the cervix dilates during labor, the cervix also drops. And so that rugae is going to allow, I'm sorry, I just realized you can't see what I'm doing. So that cervix is going to drop, bringing the vagina's distance down. Sorry. Sawyer just woke up. So that way the birth canal is a lesser distance for the baby. Hey, Dustin, can you come get the monitor? Because she just woke up. I'm almost done. Okay, so different parts of the uterus. We have the cervix here. We have this uterosacral ligament. This is going to connect the uterus to the pelvis. So again, cervix, isthmus, it's a fun word, isthmus, is just this kind of hourglass shape. The body is this thicker region, and then the fundus is the top region. We have an ovary here, which has an ovarian ligament connecting right here. And then we also have the suspensory ligament, which is going to connect to the pelvis. Now, the fallopian tube or uterine tube, most of it does not directly connect with the ovary. The ovary is where the eggs are going to be produced and released. The uterine tube needs to essentially catch the egg. And the fimbriae are these finger-like projections that kind of spread out around the area that the egg might be released. And so it's up to them to catch the egg. So again, there's the uterine tube, and this is what we call an oocyte. Oo meaning ovum, cyte meaning cell, so an egg cell. When a female goes through the ovarian cycle, the egg ruptures from within the ovary ruptures to release the egg, and these fimbriae, like I said, need to catch the egg and go into the fallopian tube. It is possible that they could miss. It's also possible for sperm to fertilize an egg outside of the fallopian tube. That's referred to as an ectopic pregnancy. It can be it can be fatal. So it typically has to be removed from the female. But these fimbriae do play an important role to making sure that the egg gets into the fallopian tube properly. Okay. The other things I want to mention, we said that the semen is going to be the fluid that contains sperm. When we say that the male reproductive system is simply to deliver sperm to the female reproductive tract, they are essentially delivering sperm to the cervix. Okay. There's a slight window of opportunity throughout a 28-day cycle, about there, in which this region of the cervix that has a mucousy area, it becomes very watery and easy for semen to travel through. So the penis, the closer it is to the cervix, especially if it coats the cervix in semen, it is then able to travel up into the uterus and into the fallopian tube to fertilize the egg. Fertilization does occur in the fallopian tube, but then it travels down into the uterus for implantation. If that embryo were to implant anywhere aside from the uterus, it's considered an ectopic pregnancy, and that can be very dangerous. And it is likely not to be viable. That includes if it were to embed up here in the fallopian tubes, outside of the fallopian tube, and even towards the cervix. Okay. Other side notes. Sorry, I thought I just heard something strange. As I mentioned before, the purpose of the male reproduction is to coat this cervix in semen. However, even if semen were just introduced to the vagina anywhere in this area, it can still make its way to the cervix and into the fallopian tubes. Semen can live 24 to 48 hours within the vagina. In some lesser often cases, it can even last up to 72 hours. And just note that a male does not have to ejaculate within the vagina for pregnancy to be possible. Pre-ejaculatory fluid can contain traces of semen. And so that's why, the pull-out method is not a viable form of birth control because you can still get pregnant from any semen traces that may be in pre-ejaculatory fluid. And if semen were to enter the vagina, even if it wasn't ejaculatory, but say introduced with an individual's fingers, pregnancy is possible there. If the semen is on the external of the body, then that's not going to cause pregnancy. But as I said, even pre-ejaculatory fluid can contain semen. If it enters the vagina, pregnancy is possible. All right, let's talk about the ovulatory cycle. You know what? I think I said ovarian cycle earlier. Yeah, that is. Okay. So we have the cycle that occurs on like a 28-day rotation. And we can see this in two ways here. Let's talk about this cycle occurring in the ovary. So I just want you to focus on A through F up here. And again, I think you know I'm probably going to go out of order. So to start off, a female is born with all the eggs she will ever have, but those eggs are not yet mature. Okay. They are still diploid, meaning that they have two sets of DNA, but they need to go through meiosis. So we have these primordial follicles. Primordial is kind of like primitive, like not ready. And from here, once they get the signal to begin developing, so once the estrogen levels in the body trigger it to do so, they will develop into these primary follicles, which are kind of spread out here. You have multiple primordial follicles, you have thousands. Each month, about 20 of them will continue on to become primaries, and then from there the number slims to where by the time we get to these primaries and the primary oocyte, which is an egg cell, only one or so, most likely just one, is going to become secondary follicle with a secondary oocyte, which is essentially the matured egg. Okay, so here we need to go through meiosis, so then we're dividing and we have this follicle here protecting it. The follicle then enlarges and we now have this mature egg. What happens is once that secondary follicle has the mature egg, it's going to rupture through the side of the ovary. Yes. So releasing of the egg means that the ovary ruptures here to release the egg. The egg is then released. That remaining follicle is the corpus luteum. And this here is going to remain for hormonal production. And then you go through the whole cycle again. The female will go through the whole cycle again if she's not impregnated. So let's look at this from a monthly standpoint. So starting off here, we have, I wish I could hold my hand on top of the screen so you could see it. The pre-ovulatory phase. Okay, if we're looking in the ovarian cycle, this is when we have the primordial, we have the primary, and we have the secondary follicles developing. Okay, so the follicle development and the oocytes are occurring in the pre-ovulatory phase. Okay, at this time, our estrogen's a little bit lower, but it's going to be raising. Okay. And our uterus down here, your uterus has two layers, the basal layer and the functional layer. The basal layer or basement layer stays the same throughout the entire 28 days. The functional layer is what changes. Okay? Okay, so menstrual cycle, 5 to 7 days. Okay, days 1 through 5-ish. Of the first 20, or days 1 to 5-ish of the 28-day cycle. From there, you then have days 6 to about 10-ish, where we have the pre-ovulatory and the secondary follicle going from primordial to secondary follicle, right? So menstrual is about 1 through 5. Proliferative, meaning that we're in that pre-ovulatory phase. Proliferative means that the uterus is going to start thickening. The walls are going to start thickening, the functional layer. Okay? Day 12 is ovulation. Ovulation means that we are now going to have the rupturing of the follicle and the release of the egg into the fallopian tube. So those fimbriae are going to catch that egg so that it can travel into the fallopian tube. Okay, so here we're at about day 12. Small window, but remember, if sperm is able to live within the vagina for 24 to 48 hours, that means it could be 24 to 48 hours before or after ovulation that sperm can reach that egg. After that, once that egg has been released into the fallopian tubes, estrogen levels are going to increase and progesterone is going to increase. Those are going to help release according to the corpus luteum. Okay, progesterone is going to encourage the thickening of the endometrium or that functional layer of the uterus. If that egg is fertilized by sperm, it will implant into this thick layer of the endometrium. That endometrium is going to be a nice home for that fertilized egg. On the other hand, if that egg is not fertilized and it passes through, that endometrium will not have anything in bed within it, and the female will then need to shed that inner layer, shed that functional layer, and prepare again for a new egg. Okay, so it's kind of like this whole cycle occurs for the coming egg at each cycle. Okay, so the first 5 days is shedding the endometrium. The next few days is preparing the endometrium, and then it's waiting for the arrival of the next egg. And the uterus is like, okay, maybe we'll get fertilized this time. Maybe there'll be implantation. And if it doesn't happen, then it starts all over again. It's like, well, that one didn't work out. We got to shed this layer and start all over again. Okay, so I'm really sorry if that was all over the place. There's just a lot of information I wanted to get to you in this brief amount of time. I'm terribly sorry that we didn't get to actually cover the units as I had planned. But what I want you to do for your assignment is to simply fill in your diagram notes, upload them to It's Learning, and you'll just save them as a PDF. And if you're not sure how to do that, I posted a video on how to save PDFs, and that's it. Guys, I'm so sad. Side note, I'll say that, you know what? I'm gonna make a goodbye video next week. But I'm very sad. You guys have been great. I know this is not how any of us anticipated the year to go, especially with me being on maternity leave in the beginning of the year, and now we're not in school at the end of the year. I feel like you got the short end of the stick, and I apologize, but if you ever have any concerns or questions or anything, college worries, career worries, anything that you want to talk to me about, questions, or if you need recommendations or anything like that, please let me know. You all have been a joy. I miss you very much. And I hope that, you've gotten a bit of info and a bit of knowledge gained through this class.